So I'm Véronique De Laet, and today I would like to present you how geographical data can benefit from artificial intelligence. So how it can help to enrich geographical data. The vision of GIM is that everything happens somewhere. 80% of the data around which are available in the world have a geographical component, have a location component. So, and this location information, especially when we use novel techniques like artificial intelligence, it can help organizations to take smarter decisions and better decisions, and to even work faster, because through these new technologies, they are able to automate some of their repetitive tasks, which they did manually or using traditional methods before. How do we do this at GIM? We work on three pillars. One is the data sourcing. So we start at GIM, we start from either the data which are provided by our customers to us, or we also have many different partnerships around data. So we can also integrate data from our partners into the analysis, or we can integrate data which we just developed ourselves. So that's the starting point. Then in the next step, we analyze these data, we integrate these data, we combine them, and we apply analysis techniques like artificial intelligence on these data sets. And then in the last step, we create new information out of these data sets. On the one hand, it can help to create this information to feed our own products, which we then can deliver to our customers, or we can also include this information in applications from our customers, or we develop something together with our customers. So that are the three steps in which, or let's say the processing chain we follow at GIM. For who do we do this? On the one hand, for the public sector, on the other hand, for the utilities market or the network operators. And for the last item, also for the private sector, so logistics, insurance, or retail. I just have a quick look, and is there something? Okay, voila. That was information about the poll, which is also very useful to take into account for this webinar. So these are the focus markets where we are into. Then our next step is like, what is geoAI? Because of course, if I want to introduce some use cases, it's good to know what's the difference between geoAI and AI or artificial intelligence in general. So AI or geoAI is a subset of artificial intelligence, and it's meant to start from data sets which have a geographical component. So in the sense that, for example, aerial photographs, topographic maps, point clouds from the surveyor world. And so all these data sets, the focus is that they also help solving spatial problems. And there is where artificial intelligence can help to analyze these data sets, these geographical data sets, to solve spatial problems. So an example here, to just make it a little bit more clear, is that, for example, you start as source data of georeferenced orthophotos. So aerial photographs taken from the air above the Earth. So that's, for example, a starting point. Then what do you want to do with these these orthophotos? For example, you want to detect the type of roof, you want to detect solar panels, which are there solar panels on top of this roof? Are there roof windows on the roof? These are examples of information you want to extract from these aerial photographs using artificial intelligence techniques. And that's where then it starts. So the next step is to create a training data set of the object you are interested in, and you identify them on the source data set. So the source data set is, in this case, the aerial photographs. So, and you do this for a representative small part of your entire area where you are interested in. For example, we do this in the area of Leuven in Belgium, and we are interested in the area of Belgium as a whole. And it's very important that the quality of this training data set, so the reference which you know is the truth, that's very accurate. Because of course, garbage in is garbage out. So if you start from a data set which is not qualitative, also your end result for the entire region where you're interested in will not be accurate enough. And then, of course, in the end, you then apply on this training data set and on your source data, in this case, aerial photographs, you apply artificial intelligence techniques, and then you get an extrapolated result for the entire country. And you can also analyze the quality of your end result in comparison with your initial training data which you collected, which is very accurate. And then you know how well your result is compared to reality. How do we do this? So we have at GM, we have developed, that's for the more maybe technical people in the room. So we have developed an AI stack specifically for geo questions. And so it's based on Python. It's a Python environment. We use also specific frameworks like TensorFlow and PyTorch. And we also have a specific geostack, including GeoPandas, Rasterio. So based on all these elements, we have created a modular framework, a modular base framework, a modular architecture, which we can then extend, adapt in function of the specific use case. So every use case is a little bit different, but we start from the same base code, let's say. And this base code is based on the elements just described. Then, what is then the added value of geoAI? The added value is that by doing or using artificial intelligence on top of geographical data, we can create better quality end products for our customers instead of what they did using either manual techniques or traditional techniques which came before artificial intelligence was well known. On the other hand, we also create more robust processing chains, which can be applied from year to year and which are also scalable. Scalable in the sense that you can extend the processing capacity easily, so you can add processing power with respect to processing bigger areas, more complex phenomenon, and also scalable in geographical territory which you are interested in. So you can work on region, you can work on countries in a much shorter time frame than what was possible before AI was introduced. Some specific attention points which we should not forget about is that specifically in AI in general, but specifically in geo, AI is evolving very fast. So it's very important that, and that's why it's one of our core businesses. It's important to follow this very closely and to always make sure you implement or integrate the latest technology evolutions, framework evolutions, architecture evolutions, in order to extract the most or the best what's possible. And this also has an effect on the quality of the end result that you can achieve. Of course, another point of attention, which I already slightly introduced, is training data. Training data are key, so you need to know what you're looking for in order to get information on a bigger territory, a bigger region for the object you are interested in. And the quality of this reference data, this training data set, is very important, because if you start with a low quality training data set, so you're not sure that every building, for example, where you identify solar panels are actually solar panels, then you will also have issues with the quality of your end result for the bigger territory. So that's very important to have a representative data set, both in distribution across the territory you're interested in the distribution across the variation of your object. Solar panels, you need to make sure that in your training data, you integrate all different types of solar panels and not just one solar panel, in order to detect all the solar panels for the rest of the area. So that's very important. So that's a little bit the introduction of what we do at GIM, our focus domains, and also what is geoAI. And now I will explain you in more detail what geoAI is and for what it can be used, based on some use cases we developed at GIM and which are coming from our customers. So for example, geoAI can be used in the framework of marketing and prospection. A recurrent question that we get is, can you provide me all the addresses of, for example, buildings with a swimming pool, or buildings with a garden bigger than 2,000 square meters, or a combination of both, or buildings with roof windows, for example, or buildings which are older than or younger than a specific age. These are all questions which we can answer through applying artificial intelligence, in this case, based on orthophotos or aerial photographs. Why do our customers use this information? For example, in the framework of marketing and prospection. A company who is delivering or distributing grass mowers, they are interested in the bigger gardens, and where are these bigger gardens located, to really specifically target these buildings, or the people living in these buildings, with specific marketing actions. The same can be for a company who is constructing or swimming pools, or providing products for the maintenance of swimming pools. They are also benefiting from who are their customers and where do they live. In the insurance sector, for example, today you don't go anymore to the bank or to your insurer to ask for an offer for your insurance, but you do this all digitally online. And so for these aspects, for example, an insurer needs to know, specifically then for industrial parcels, are there fire risk augmenting activities present on that parcel. And also with this question, we can help them using AI on aerial photographs, for example. Or a government, with respect to their policy in the framework of the Green Deal, the government want to know, or local or regional government want to know how much of an area of a parcel is sealed. So they can take specific actions with respect to decrease the amount of sealing area within their community, within the region. And so for all these aspects, we use artificial intelligence to generate this information and to help these organizations in the use of these data and to creation of these data. So we have, for example, a database of all addresses and buildings within the Benelux, and connected to this, every building has also explicitly some extra parameters, like are there solar panels or not? Are there swimming pool? Is there a swimming pool or not? Are there roof windows or not? What's the building age of this building? What's the land cover of the parcel the building is situated on? So all this information is derived using artificial intelligence techniques and is integrated and combined into a database, which can be delivered as a database, or which can be using APIs. A connection can be made from an external application to our database. And so here are a couple of, which I already mentioned, a couple of features or modules which we can provide and which are derived using artificial intelligence. For example, land use, land cover, aircrew units, building age. And this is just a start, because the number of modules or features which can be derived from data using artificial intelligence techniques is of course huge. For example, what is the facade? What's the building material of the facade? What's the building material of the roof? Voila. So this is, let's say, endless. So it's still many features still to come in order to have a full digital twin of our urban reality. Voila, so this is an example specifically then for building age, how AI can help to derive the information on building age. So we used topographic maps, other data sets which were available using other data sets which were already providing some information on building age, aerial photographs of different years. So you could see a building which is not present in year 1, but which is present in year 1 plus 2. Okay, then you know, okay, it's younger than the orthophoto of year 1, and it has been constructed in between year 1 and year 1 plus 2. So this is how we constructed, and all this information is combined in an artificial intelligence framework. And through this information, we were able to create a data set which provides for every building the building age of that building. So this is just an example of how we derived all the other features which I just mentioned. The same is like here, you have solar panels. You see the solar panels on the roof of the building here on the left. And you see how we, let's say, created the training data set. And then also the next step is then to map the entire or check this for every building in the Benelux. The same we did for roof windows. Also, we applied the same technique. We defined on a certain sample of buildings, we identified the roof windows, and then using AI techniques, we extrapolated that for the entire Benelux in order to map all roof windows. So that's a little bit about the digital twin and how artificial can help to create and enhance a digital twin of the reality and the use cases which can benefit from this framework. Another item is geoAI for asset management. These days, utility companies with high voltage power lines, with rail networks, for them, it's very important. Also in the framework of public lighting, it's very important to have an accurate idea of the amount of vegetation, where is vegetation encroaching electric power lines, rail networks, in order to have an idea on the maintenance budgets that need to be foreseen for these assets, or to control the quality of the work, what has been done, and also define the right moment in time when maintenance should occur. So through artificial intelligence, we were able to cover large areas in a limited amount of time. So for example, if the data are available within just a few weeks, we can map and inventory a trajectory of, for example, 2,000 kilometers of high voltage power lines and identify the areas which are risky for encroachment. If this should have been done using manual work on the ground, it would take a long time. And the advantage is also that you can do this year by year in a repetitive mode in order to monitor what's going on. So this is, for example, for power lines and for railroads. So how do we do this? For Belgium, for example, we derived a land cover map using 9 classes. of which a class is trees, grass, and bushes, so high vegetation and low vegetation. We also have a class on covered, so sealed areas, railroads and roads. And so through this data set, we apply the same principles also abroad. We can identify the areas and the percentage of densely high vegetated areas, and to see, for example, along a high voltage power line where cutting has not been done properly, or where it should be done next the year after, for example. The same we did for a governmental organization. And so we mapped all the vegetation assets in close vicinity of the waterways, so they can better budget and have an idea of what budget they need to foresee on the monitoring or the management, the maintenance of this vegetation. Another item where this data set and so artificial intelligence can be of benefit is with respect to the fiber rollout. Fiber rollout is a quite expensive thing to do. And so it's very important to have also accurate estimations of the cost of the rollout of this fiber network. So for example, if you have to dig through a sealed area, or whether an area is just bare soil, the cost linked to it is just very different. And it's so very important to inventorize this upfront, and so to have a good idea of these costs. And this is possible through these artificial derived land cover map based on aerial photographs. Then a last topic which I would like to introduce, and where at GIM we a focus area where we focus on, is sustainable development goals. So we some of our customers are the United Nations or the World Bank, and so they are interested in knowing for specific areas where are informal settlements situated, in order to develop their urban development policies, to take specific actions. So what we did in both South America and Asia is to map for large cities, the entire city, all the informal settlement areas in these cities. Why is this important? That I will show you within a few minutes. And so that is, and so we also created really an open source toolbox around it. So we only did not do this in a project context, but we also provided them a tool which they can roll out within the United Nations or within the World Bank to apply it themselves on other cities without our help. So in a kind of trainer program, we help them to setting up, to deploy this toolbox, and so also help them to learn how to use it, so they can now use it on their own in the areas where they want to. So also here, with respect to informal settlement mappings, the advantage is that you can cover large areas. Traditionally, they just went into the field and they did surveys, really enquete surveys, to get this information. And the other advantage is that you can execute these measurements with much higher frequencies than you would do before. The other item is that you also have the possibility to use it on different data. So you have imagery with very high detail, but you also have sometimes a local government which is only able to have information with a much lower quality. And so we have created a toolbox which can make use of different quality type of data sets. And the last point, which is of benefit, is that it's open source, so it can be applied by a wide range of people and organizations in a train-the-trainer program. What's next then? So why is this data useful? On the one hand, it's important to know where these settlements are located in order to develop urban development policies. But on the other hand, you can also apply this year by year or in subsets of, for example, 5 years in order to map and inventorize the growth of a city or a certain area within developing countries. And so there you can also see how exponentially or how the area is growing, and also take specific measures in this respect. So that's on the one hand. On the other hand, you can also map this or make the relation with natural hazards. So you can see where are my informal settlements located, or settlements in general. It doesn't need to be, you can also create the same model for just settlements, not specifically informal settlements. And you can then see, okay, and where are my natural hazards occurring? And is there a relation? What is the correlation between both, or what's the relation between both? And then also take specific urban development measures or scenario building to support the people living in these areas. Finally, it's also a mean. So if you have information on informal settlements and you have information on, for example, services like where are my hospitals, where are my schools, where are the people working, so where's the working area, then you can also investigate, are they both well connected? Are they just not properly organized? So you can also adapt your urban development policies to make, let's say, services available in the most optimal way to the people living into your city, for example. And also here, we just apply statistical methods, but also artificial intelligence, first to map the informal settlements or settlements in general, and to make the connection with hospitals, school, or in general, the key services. And so in this respect, we help also these organizations in delivering their sustainable development goals with respect to no poverty, industry, innovation, and infrastructure, or sustainable cities and communities. So this was the different topics and different use cases, or just an extract of the use cases we work on at GIM. And yeah, I hope you find them interesting. If you have yourself a use case which you think, ah, yeah, this is interesting, but I cannot, I need support to work it out using artificial intelligence or not, here you have my contact details. And so I'm happy to help you out and to reflect together on how we could help you further.